to now, we've talked about graphs for quantitative data. So these were the numbers. We talked about histograms, polygons, ogives, stem and leaf plots, and then more recently, box plots. Today, we'll talk about graphs for qualitative data. So these are labels and categories. Usually, these are going to be words. So here I have colors. Right? These are colors of M&Ms. So colors are words. So this is going to be qualitative data. The first thing I'm going to do is I'm going to summarize my data using a table. Right? So distribution is just another word for make a table. So I'm going to start here by listing out all of my possible data values here. So all of my possible colors. So I have yellow, orange, brown, green, blue, red. Right? So I'm going to list out all my possible colors. Yellow, orange, brown, green, blue, and we said red. Okay, now I'm going to find the frequencies. And frequency just means how many. So I'm going to count how many yellows I have, how many oranges I have. I'll just tell you here that there's 10 yellows, there's 6 oranges, 12 browns, 5 greens, 3 blues, and 9 reds. Relative frequency. I know there's 10 yellows, okay? Relative frequency is asking what percentage is that. So what percentage of the total is yellow? So I'm going to first now count the total frequency. Okay, you can get this by either counting how many data values you have or just adding up the frequencies. So adding up the frequencies, 10 plus 6 plus 12 plus 5 plus 3 plus 9 is 45. So 10 out of 45 is yellow. Okay, 10 out of 45 is 0.222, rounded through 3 decimal places here. 6 out of 45 is orange. And 6 out of 45 is 0.133. Remember that these are really percentages, right? So 22.2% of the colors are yellow, 13.3% are orange. And then let me tell you the rest here. So 12 out of 45. Okay, so for quantitative data, we also talked about cumulative frequency and cumulative relative frequency. So it doesn't make sense to talk about that here because cumulative frequency would mean you're adding 12 and then everything before it, right? So before, the word before means that things are in order. But when we're talking about colors, there's no order to colors. So it doesn't make sense to add up all the colors before brown, right? So what does it mean to be before brown? So it doesn't make sense here to talk about cumulative frequency or cumulative relative frequency. The main graph for a qualitative data is going to be a bar graph. So I'm going to put frequency on the y-axis. Frequencies go all the way up to 12 here. Let me count by twos. 2, 4, 6, 8, 10, 12. Okay, these are my frequencies. And I'm going to represent my frequencies using bars. For yellow, frequency is 10, so I should have a bar of height 10. Orange, should have height 6. Okay, notice that my bars have gaps. When we talked about quantitative data and we were talking about histograms, remember that the bars have no gaps, they touch. So here, for qualitative data, the bars are going to have gaps. Next up is brown. Oh, green, blue. Okay, and then to help my reader, I'm gonna label the bars with the frequencies. Yellow was 10, orange was 6, 12 for brown, 5, 3, 9. Okay, that's a frequency bar graph. A relative frequency bar graph is the same thing, except instead of frequency, you'll put the relative frequency. And then finally, a frequency Pareto chart. It's going to be exactly the same as a bar graph. The only difference is you're going to reorder the bars with the highest bar first, and then you go downward. Right? So it's the same as the bar graph. Except you're going to put the in order from largest to smallest frequency. A Pareto chart would mean you're going to put the 12 first, then the 10, then the 9, 6, 5, and 3. And that's it. Another common graph for qualitative data are pie charts. So pie charts, you're showing the percentages, right? Which are really just the relative frequencies, right? Because if you have relative frequency, you can convert that to a percent. And the slice of the pie represents the percent. So if you have a larger percent, you should have a larger slice of the pie. If you have a smaller percent, you should have a smaller slice of the pie. If I add up all the percentages, what should you get? If I add up all the percentages, right, that should represent the entire pie, and the entire pie should represent 100%. At the bottom here, these are some bad pie charts. This is from 2012, and this was more recent. Stare at these and make sure you see why these are bad pie charts. Okay, so we'll end this unit talking about graphs that deceive. So if you're trying to deceive people, this is how you do it. If you're not trying to deceive people, then don't do what I'm about to show you. Here we have two graphs. These are showing the highway fuel consumption miles per gallon. So this is how many miles your car can travel on 1 gallon of gas. So the higher the bar is, the more efficient your car is. The farther your car can go on the same amount of gas. So what's different about these two graphs? Okay, they're both about Honda Civic, Chevrolet Aveo, Toyota Camry, right? Same cars. Honda Civic on the left picture is around 36 miles per gallon. On the right picture, also around 36 miles per gallon. Left picture, Chevy Aveo, around 34. On the right picture, also around 34. Toyota Camry, left picture, 31. Right picture, also around 31. Both of these graphs are showing the same data, right? What's the difference? Notice that the graph on the left starts their y-axis at 30. Graph on the right starts the y-axis at 0. So the one on the right is the more accurate picture. So you're supposed to do the one on the right, right? You should always start your y-axis at 0. Now, why would you cut off the y-axis and start it at 30? Both these graphs are showing the same data, right? But if you're Honda Civic, which graph are you going to use? Which graph are you going to put in your commercials? You're going to put the graph on the left, right? The graph on the left, it looks like Honda Civic is way better than Chevrolet Aveo and Toyota Camry. Whereas the graph on the right, Honda Civic is better, but it doesn't look like it's that much better, right? It's slightly better than these other two cars. But the graph on the left, it looks like it's way better, especially compared to Toyota Camry, right? Toyota Camry's way down here, Honda Civic's way up here. So the effect of cutting off your y-axis and starting it at something other than 0 has the effect of exaggerating any differences, right? Graph on the right is more accurate, so that's what you're supposed to do. But if you want to deceive people and exaggerate the differences, cut off your y-axis. And people do this all the time. So if you pay attention to the news, you'll see examples of these everywhere. So here's an example. Now the tax rate is 35%. January 1st, it jumps all the way up to 39.6%, right? Big jump. But look what they're doing. They're cutting the y-axis at 34. Okay, so anytime you see the y-axis being cut, you should always ask yourself, why are they cutting it? What are they trying to exaggerate something? Or do they just not know what they're doing? Okay, here's another example. Okay, it looks like between 1998 and 2012, this is what the temperature from 54.32 to 55.3 looks like it almost doubled, right? But in reality, it only went from 54.32 to 55.3, and they cut off the y-axis at 53. Here's something else that you shouldn't do. Okay, so what's this picture trying to show you? In 1986, the subway fare is $1, and currently the subway fare is $2. So the picture is trying to show you that the subway fare went from $1 to $2, so it doubled, right? But what could be deceiving is how many of these $1 can you fit inside of this $2? It looks like you might be able to fit 4 of these $1 inside of this $2, right? So if the reader is not paying attention, it may look like the subway fare went up by a factor of 4, it quadrupled, when in fact it only doubled. Okay, and then here's another example of the same issue. Previous iPad, this is the new iPad, so they're trying to show that the battery life increased. So I think the correct data is that the battery life went up by like a factor of 1.5. Right? It didn't double, but by a factor of 1.5. But for a reader who's not paying attention, it may look like you can fit more than 2 of these small batteries inside the big battery, and so that can be deceiving. The last graph I want to show you is this one. So this one appeared in the news. It shows gun deaths in Florida, number of murders committed using firearms. It has marked on here that in 2005, Florida enacted its Stand Your Ground law. So after this law was enacted, did the murders go up or down? It looks like it went down. But what's weird about this graph? What's weird is the y-axis. Okay, the y-axis is upside down. 0 is up top, and then 800 is at the bottom. So even though it looks like it went downward, right, but downward represents bigger numbers. So in fact, after the Stand Your Ground law was enacted, the murders went up. It increased. So why would anybody do it like this? Why would you flip around your y-axis? So the person here, C. Chan at the bottom here, this person was trying to be cute. The red here is supposed to represent blood, and they were trying to make a graphic that looked like dripping blood, which is why they flipped the y-axis and put the 0 at the top. Don't do this. It doesn't make sense. It doesn't make sense to the reader.